My name is Joseph Wunderlich. I'm a professor of engineering, architecture, and computer science, and this is a short video just talking about this paper, Breaking the Multicore Bottleneck, which is referring to a way to increase performance and somewhat overcome the scalability problem and the interprocessor communication problem when you have shared memory in an SMP type system. They have their queue management device, and what they are doing is treating the cores as network nodes, where on a computer network and in queuing theory, the more nodes you have, you can increase performance. So in Amdahl's law, you have a law of diminishing returns, law of diminishing marginal utility in economic terms, or any optimization, where you don't always get the same amount of benefit from each incremental bit of cost, and that is found in Amdahl's law for scalability in computing, where you're talking about the number of processors and how much speed up you get with each processor, each core. It also applies to the amount of parallelizable code and the hardware that can allow that as a percentage basis within your optimization. And so what you see here is they're claiming that you can get increased performance and improve beyond the bottleneck, which is Amdahl's law, of scalability. The green line where optimal performance, ideal performance, is that you can't get more than twice the speed up out of 2 cores, or 3 times the speed up out of 3 cores. You just can't exceed that. It's not logical. But you can improve on what you see as the upper bound of Amdahl's law on the graph on this page, and start bending it upwards with more cores if you're doing this network type of protocol, this network routing, queuing theory, internet packet routing type protocol. Also applicable to traffic engineering, cars, and going intersections on a grid.